The next is geologic phenomenon, and that's what I like to talk about, the layers and the fossils and the coal and the oil. As being trained as a geologist, this is where I enjoy talking. I think it doesn't look old. I think it looks flooded, and I think I'll be able to show you why. We began last time looking at the article in New York Times, or ended last time looking at this article, which talked about signs of great floods on Mars. Now, they have no problem seeing floods on Mars where there's no water there today. Scientists are recognizing the awesome magnitude of a deluge that swept over much of the red planet, a catastrophe that perhaps only Noah could appreciate. Well, isn't that an interesting description? No water up there, but Noah could appreciate this. When you see sedimentary layers like this on Earth, where 70% of the surface is covered by water, no, it's not a flood. Discover was commenting on this in 2018. Catastrophic floods rapidly carved the surface of Mars. And then the pictures show exactly the kind of thing that we see on Earth. And here, May 5th, 2020, I believe that's up to date, we see the description, Mars Noachic stratigraphic record. Noachian, wow. That's the way they describe the stratigraphic record with Noah and his flood. Well, when you look at Grand Canyon, you see a perfect example of exactly what they're talking about. And the Earth is covered to an average of about 1.5 miles of these sedimentary layers with billions and billions of dead things in it. Now, if you believed in a worldwide flood, what would you expect to see? These layers that look like they were laid down by a flood, as long as it's on Mars, and billions and billions of dead things in it. And the surface of the Earth is covered, 70% of it, up to about 3 miles deep or more, on average. Lots of water here, without water on Mars, but lots of water, and they refuse to see a flood on Earth. They avoid the implications by saying, no, this took millions and millions of years, and use the radiometric dating systems to support that, which is not real good reason. The idea that is taught in school would be represented here in the book Great Dinosaur Extinction by Officer and Drake. And they're talking about the rate of the formation. These layers form very, very slowly. Now, I think we'll show evidence that they did not. They formed rapidly, but the rate they're proposing is a rate of 1 centimeter per 1,000 years is typical. Now, that would mean you've got lots and lots of years represented there at Grand Canyon. But when people who study the rocks and the fossils look at this, there is a significant problem. As indicated here in the book Principles of Stratigraphy, I was taught from at 2 different state universities, to some thoughtful stratigraphers, those who study the strata, this presented a dilemma. Because, he says, there's very good evidence that individual beds accumulated not slowly, not half an inch for 1,000 years, but rapidly. And then he gives some examples. You look at fossil shrimp. Now, you ladies know that you can take the shrimp and put it in the refrigerator and it'll just last for years and years and years, or not. How long did it take this rock to form? How long would the shrimp look like that before it deteriorated? Like maybe a day or 2, and it begins to deteriorate. These are perfect. Now just think about it. I mean, it won't hurt. Just think, how long could you take to form a rock like, and have these shrimp remain looking like this? I have in my museum a collection of what are called aspirations, fish in the process of eating their supper. Now, I like to eat with my brethren and friends, and some of them are maybe a little aggravating. They take a long time to eat, and you have to sit and wait, but millions of years is kind of ridiculous. if this sediment was forming at, rock was forming at the rate of half an inch per 1,000 years, how in the world would you get pictures like this of fish in the process of eating their supper? Now, it didn't take that long for them to eat their supper. And then there are others that just, I mean, this defies the slow, gradual. But with newer examples, I mean, it's just getting more and more dramatic. Here is from last year, a school of fish captured in a fossil. Now, they're in formation. And if this is forming at the rate of half an inch in 1,000 years, you see a problem here? In fact, the scale is given here in this article, 10 representing 1 centimeter. 10 centimeters, millimeters represent 1 centimeter, and that's represented here in the square. And so the magnified square there shows you what happens, according to Officer and Drake, in 1,000 years. Well, it takes 1,000 years to get just that much of it. And they're still in formation when they're formed. Roy Plotnick, paleontologist, University of Illinois, said, I can't picture a three-dimensional school of fish sinking to the bottom and maintaining their relative positions. This makes no sense to me. No, it makes no sense at all. It's not possible to do that slowly. But he believes it. And he goes on to say, well, yeah, there it has to happen. It has to happen slowly. He believes the impossible. Maybe he needs some help from the Red Queen. You remember Alice in Wonderland says, there's no use trying. You can't believe impossible things, which he's trying to do. And the Red Queen says, I dare say you haven't had much practice. When I was your age, I did it for half an hour a day. Sometimes I believed as many as 6 impossible things before breakfast. And yeah, Mr. Plotnick has to believe the impossible, and he does, but it takes some practice, I guess. But things are not getting better. Here, from just a few months ago in Nature, is another report that defies the slow, gradual picture. Here's a lineup. Trilobites playing Follow the Leader. Now, this is the headline from Nature. They're playing Follow the Leader. And that game of Follow the Leader is preserved in the rock. Now, notice the text from Nature. Trilobites go marching one by one. Hurrah, hurrah. At least that's what some of them did 480 million years ago. However, whatever took their lives didn't even disrupt the trilobites' careful cue. It preserved them playing. How do you do that at half an inch per 1,000 years? That's just really impossible. Many, many examples. This is a picture up in the Cumberland Mountains just above Knoxville, Tennessee. And you see the coal seam down at the bottom. They were mining coal. This is strip mining. And revealed this fossil fern. This is not a tree, but this one is 12 feet tall. I'm sitting here beside it, sitting in the coal seam. But this tells us something about the coal that this is extending into. It extends up into another coal seam above, and there's 12 feet. Now, 12 feet divided by half an inch gives you a long period of time, but what happens to the top of the fern over that long period of time? In fact, as you get a wider view here, you see that there are 4 of these trees and several others that are not in the picture. How do you explain these ferns perfectly preserved from top to bottom? I think there's a better explanation. I think this is one catastrophic event that preserved this in place, rather than half an inch per 1,000 years preserving that fern 12 feet tall. Many of you have seen fossils of fern leaves, And looking at this one, how long does it take a fern to wilt? Well, how long did it take this fossil to form? This is in coal, by the way. And here is a picture of the fern that is bent over in life, like what you see held bent in the fossil. It formed the rock, or the coal, before it had time to spring back, while it's still bent, before it had time to wilt. Now, how long does it take a fern to wilt? This happens so quickly. We read in Science Daily that some of the cells have been preserved during different stages of cell division. It catches cell division in the process. We'll look at more examples of that in a minute. Found cell nuclei, membranes, even individual chromosomes. Now, it didn't wilt. It's in great shape, and it's preserved perfectly before it had time to deteriorate. Now, at the bottom of the picture we just looked at, this coal was in the coal seam that the fossil fern extended through. Coal then had to form rapidly as well. Oil fits into the same category, but we're told it takes millions and millions of years to form oil. I'll hear from the U.S. Department of Energy. They're talking about forming it from algae in minutes in the lab. Crude oil, less than an hour. If you see it happening in the lab, this is more scientific than imagining the millions of years that we don't see, isn't it? That we can see, we can demonstrate. Some of the fossils I just really enjoy looking at and studying. This is an ichthyosaur, which is a reptile, found recently, 2018. This one in England, and it's 28 feet from one end to the other. Beautifully preserved, and looking closely, you see the adipose tissue, fatty tissue up at the top that is beautifully preserved in the rock. How long would that stay looking like that? Beautiful preservation. And in the interior, we see this is a mommy ichthyosaur. We see the baby inside the mother, preserved in the fossil. But several in this deposit, this is from the Solnhofen limestone in Germany, were obviously buried, and this was a traumatic situation that produced premature birth in several of them, and we can see baby ichthyosaur emerging from the birth canal. Now, I can sympathize with the ladies that may think this takes millions of years to finish, but it really doesn't, does it? It doesn't take that long, but it is part of this really good evidence, the principles of stratigraphy we're talking about, that it caused a dilemma with those who study the fossils. Looking at the rocks, this is not going to happen slowly. Here in PLOS 2014, a detailed picture of the birth process. Capture the moment of live birth with a baby emerging from the pelvis of its mother. We might call it a Kodak moment. Not thousands of years. Very good evidence that it happened rapidly. And then we see some living things that just are very ephemeral in their nature. I mean, they're not going to last a long time, are they? But these jellyfish lasted long enough to form fossils. I was lecturing in a junior high class not long ago and asking the students, what is a jellyfish made of? And one of the little girls waving her hand said, I know, said, it's made out of snot. Well, not quite, but it's that kind of stuff, but it's substantial enough to form a fossil. And here they are formed beautifully, preserved in the rock. How long did it take that to form? How long would the jellyfish look like this while the rock is forming? And there are hundreds of them about the size of a dinner plate in this instance, along with the ripple marks which themselves move from moment to moment but are preserved in the rock. There's very good evidence, according to Dunbar and Rogers, in the principles of stratigraphy, that the individual beds formed rapidly. Why? Well, you see jellyfish in them. You see the shrimp. You see fish eating their supper. Mommy ichthyosaur giving birth. 12-foot ferns upright. Hundreds of layers surrounding it. Top preserved just as well as the bottom. Very good evidence that the individual beds accumulated rapidly. You see schools of fish preserved as schools, and you see follow the leader with the trilobites preserved, and this is not going to happen slowly. But you can't admit that, or then you give up evolution. That's the challenge. You see lots of examples of preserved soft tissue in the Burgess Shale. And we've known about this for a long time. Soft tissue in exquisite detail here, repeated in PhysOrg. And here's one of the pictures of the caterpillar-type critter, centipede. And the soft, not hard bones, but soft tissue preserved beautifully in the rock. The question of how this came to happen has troubled scientists since the discovery of the fossils in 1909. Now, we looked at examples from just a few months ago and a couple of years ago, but they've known about this since 1909, and it's troubled scientists. They knew about the problem. Since 1909, they've been trying to solve it, and it's still troubling, and it's gotten worse. We have soft tissue, like the jellyfish, preserved in the rock. That's troubled scientists. But what about soft tissue that is still soft? Now, soft tissue preserved in the rock had to happen quickly, but soft tissue that's still soft, how does that happen? Like blood cells in a T-Rex bone, supposed to be 65 million years old, but you still have soft tissue in the dinosaur bone. Here's Mary Schweitzer several years ago in Discover magazine showing the soft tissue in a T-Rex femur. And you stretch it and it snaps back. It is stretchy. That's not the kind of organic material that's going to last for millions of years. It doesn't last for months. The real challenge is how did it last for a few thousand years since the flood for creationists. But here is material inside a dinosaur bone, reported in Discover. I had one reviewer tell me he didn't care what the data said. He knew that what I was finding wasn't possible. Now, this is not the way scientists ought to be looking at data. Yeah, I see it, but it's not possible. And so she said, I wrote back and said, what data would convince you? He said, none. He's not troubled by this. He just closes his eyes and it all goes away, I guess. This is not science. But it's gotten worse since this was found. Many had come up with examples or scenarios they could imagine to explain this away. Maybe bacteria was being reported. Maybe this was biofilm. Maybe in all kinds. And finally, one by one, that those explanations dropped to the wayside, and more was found. And here, reported this year in PhysOrg, dinosaur skeletons with fossilized chromosomes, preserved DNA. What next? It's getting worse and worse and worse. For the evolutionist, DNA deteriorates rapidly. We have to repair our own DNA every day. The cosmic radiation will cause damage, and mutagenic chemicals will. And when the critter dies, then it's deteriorating rapidly. In one of the examples, here in this same article, they also mentioned that they had found two cartilage cells together, linked together by an intercellular bridge morphologically consistent with the end of cell division. We're looking at two cells dividing in the dinosaur bone. Now that process takes 20 minutes, and it's preserved in the bone. Are we thinking about this and the implications? Let me illustrate it this way. Here's a block of ice, and we see frozen in the block of ice a glass of Alka-Seltzer. Now, it takes a minute and a half for that Alka-Seltzer to completely complete its fizzing. And this is not completed. It's frozen in the block of ice. Now, how long did it take the block to freeze? Well, it must have taken an hour. Now, wait a minute. It takes a minute and a half. The fizzing is gone, and it froze before the fizzing was gone. Took no longer. It would have to take about half of the minute and a half, because it's about halfway through the process. Now, cell division takes 20 minutes to complete, and here it is frozen in the rock. So how long did it take the rock to form? Come on, let's think about it. It won't hurt the creationist anyway, but thinking about it may hurt the evolutionist when he looks at this and says, this is a major problem to try to explain slowly. The idea of original DNA in the dinosaur, as in this article just recently, February of this year, original DNA. Now, we've known this for half a dozen years. They haven't admitted it. They just avoided it like the plague because the DNA deteriorates so quickly. But here it is preserved in the rock. The article goes on to say the possibility that DNA can survive for tens of millions of years is not currently recognized by the scientific community. In other words, they know better. It is generally accepted that DNA persists less than 1 million years. The theoretical conclusions were reached based on the sample being near absolute zero, that it could maybe last 1 million years. But you're looking at least 65 million with a dinosaur. And the Hill Creek Formation in Colorado is not near zero. It's very hot many times. This comment was made by Michael Benton, who's one of the leading authorities in this field, famous British scientist. He says, we now, and he's objecting, he says, we have to find an answer. We don't have one, but we're working. We know that DNA molecules break down very easily and typically survive only a few years. 100-year-old samples, 100-year-old in the museum specimens are massively fragmented. The breakdown of molecular structure continues rapidly. By using massive computing resources, DNA from maybe 50,000-year-old fossils can be reconstructed for short sections. The oldest that we've been able to do, he says, is 700,000, but that's a long ways from 65 million. So you see the problem. We've got in the dinosaur bones soft tissue, DNA, which says just beyond any doubt that these fossils are not old. And if the fossils are not old, think about it now. If the fossils are not old, what does that say about the layers? The layers that the fossils are in can't be old either, can they? There are other reasons why these layers can't be old that we'll be looking at in our next session. We thank you for tuning in with us today. We'd encourage you to worship with us at 10:30 today at the Little Rock Church of Christ. We'll be continuing to look at scientific evidence that indicates that our faith is substantiated and justified, and we can defend it from science as well as from the Bible. But thank you for being with us today.